have to be able to change forms in order to successfully solve exponential and logarithm equations. In the first one, we're taking 3 to the 4th power equals 81, and we're writing that in logarithm form. We'll start with the base, which is the 3. And then we say logarithm is exponent. And the only number left is the 81. You'll hear that several times. In the second one, we're going to do the same process. Number 1, the base is 1/2. Number at the bottom of the log. Number 2, the logarithm is the exponent. And the only thing left is the 8. Number 3, the base is 10. The logarithm is the exponent. And the number that's left is the 1000. D, the base is 5. The logarithm is the exponent. And the only thing left is the 1 over 125. E, the base is 9. The logarithm is the exponent. And the other number is a 1. And finally, the base is 6. The logarithm is the exponent. The other number is 0. Using the transformation formula, this is equivalent to having base x, the logarithm is the exponent, and then the other number would be the 16/9. Now the x to the negative 2 is the same as 1 over x to the positive 2. If we invert both sides, we'd have an x squared and a 9 over 16. To get the x by itself, we do the square root of both sides with plus and minus. So x is plus or minus square root of 9/16, which is 3/4. However, in logarithms, the base cannot be negative, so the only answer that would be viable is the positive 3/4. Again, we will transform this into exponential form. The base is 16. Logarithm is exponent. And x is all that remains. So basically, we've already solved it. 16 to the 3/4 can be typed on our calculator. Let me remind you that it's the same as the 4th root of 16 cubed. That's what the 3/4 means. The 4th root of 16 is 2, and 2 cubed is 8. So we have solved to get x equals 8. Now in this one, since the x is already by itself on one side of the equals, then it's already solved. However, we do need to simplify and rewrite the expression log base 36 of the square root of 6. The easiest way of doing that would be to type it into your calculator. I'll let you try that, and I'll show you the algebra that they was wanting us to perform. Using our same transformation formula, the base is 36, the exponent is x, and the other number is the square root of 6. The square root of 6 is the same as 6 to the 1/2. 36 is the same as 6 squared. So we have 6 to the 2x equals 6 to the 1/2. And the only way that these two can be equal, since the bases are the same, is for 2x to be equal to the 1/2. And if we divide by both sides by 2, we get x equals 1/4. We'll be using our calculator a lot for graphing these. If you need help with anything I'm about to do, you'll need to ask about it in class because I don't show every key to push on the calculator. We'll begin by going to our y equals and entering the function log base 1/3 of x. Then we'll take a look at the graph. Now this is not sufficient information for us to actually construct a graph ourselves, so we will have a look at the table. So in the table we see that there is a dot at 1, 0, and there is a dot at 3, -1. Also, I might notice there's a dot at 9, -2. That would be way over here on the edge of our graph. And I know that this never, see the error message, never touches the y-axis. So this is our sketch of the graph. So here we will repeat the same process. Type the log base 5 of x in the y1. Look at the graph, and then take a look at the table. So again, we've got a dot at 1, 0. That's very common with logarithms. We also have a dot at 5, 1. I also know that it does not touch the y-axis. So there would be the sketch of our graph. I want to show you this one without the calculator, and then pull up the calculator to sort of verify what I have done. I'm looking at this, and I'm thinking the log base 2 of x would look something like this. We would have a dot at 1. Since it's base 2, we would have a dot at 2, 1. There would also be a dot at 4, 2, and it would go forever in this direction, but never go past the y-axis. Now that's log base 2 of x. The log base 2 of x plus 2 is that same picture shifted to the left 2 units. So each of these dots shifted to the left 2 units would still have a shape like that. However, you notice the asymptote, which was on the y-axis, is now going to be here. So this graph never goes past the line x equals -2. So there, in red, is the graph of log base 2 of x plus 2. Here, on my calculator, is the log base 2 of x plus 2. notice how we have parentheses around the x plus 2. Here's the graph, and again that does look a lot like my red line, except it's blue of course. And there's the table of values with the dots where we have them. Here's the -1, 0, -1, 0. Here's the 0, 1, and here's the 2, 2. And again, I'll do this one the same way. There will be a dot at 1, 0. If this was log base 4 of x, without the plus 2, there would be a dot at 4, 1. Now the next dot of note would be way out at 16, 2, which we don't have on our scale. So again, this one goes a lot lower than the last one, but it still does not go past the y-axis. And the plus 2 tells us that it's shifted up 2. If we take each of these dots and move it up 2 units, draw that same shape, and there would be the graph. Here it is on the calculator. Notice again the placement of the parentheses. There's parentheses right before and after the x, and then the plus 2 is outside of the parentheses. There's the picture and the table. The properties of logarithms mimic the properties of exponents. So one property of exponents is when you multiply two things with the same base, you add their exponents. In this first example, we are multiplying two things with the same base. So we're going to add their exponents. One exponent and the other exponent. So we're changing the one logarithm into two logarithms. We're going to have an 8 on one, 6 on the other, and the same base as the logarithm we started with. So there's property 1 of logarithms. Second property of exponents says when you divide two things that have the same base, you subtract exponents. So transforming that into logarithm notation, here we are dividing two things that have the same base. So we subtract exponents. And in the order top and bottom, both with the same base. The final property of exponents says when we have something with an exponent raised to an exponent, we multiply exponents. So first thing we're going to do is rewrite this as 9 to the 1/3 power. So here we have something with an exponent raised to an exponent. So we're going to multiply exponents. One exponent is the 1/3. The other exponent is the disguised exponent. So there's the three properties of logarithms. So here's how those properties work. On the first one, if we take these two terms that are subtracted. If you go back, you can rewind the video and look. The subtraction of two logarithms goes with the dividing. So this is still base 4, since all the logs are base 4, and x over y. So the log base 4 of x minus the log base 4 of y is the same as log base 4 of x divided by y. Now that still has the log base 4 of z added on to it. However, using the properties of logarithms, the plus says we can put these two together into one by multiplying the x, y, and the z. Now that can be written as the log base 4 of x, z over y. The b part, we can use that property 3 of exponents and rewrite this so that the 4 is in the exponent and the 5 is the exponent. So that's equivalent to having a log base b of r4 and a log base b of s to the 5. And the minus, just like in the original problem, means we can write this as a single logarithm with the r4 and the s5 divided. The last one, similar to the first one, needs to be put together two at a time. So these two first. We'll do the same thing we did on the b part. We'll take the 1/3 and write it in the exponent, and the 2/3 in the exponent. So this is the same as the log base a of x to the 1/3 plus the log base a of y to the 2/3. We can now put those together into a single log base a of x 1/3 y 2/3 multiplied. Now, when we put that together with the log base a of xy, the minus says we can write them as one logarithm that's divided. The x 1/3 y 2/3 on top and the x y on bottom. Now there are some more things that we could do to make the looks of that different, such as the 1/3 exponent really means a cube root. So this could be written as the cube root of xy squared over xy.